Hey robot makers, how are you doing? Hope you're having a good day so far. I'm having an excellent weekend so far. So let me get into this and we can talk all about it. So Matthias is just asking how many 3D printers I have. I just have the one. I did have two, but I had to sell that one because I didn't have space at the time. I've now got loads of space. So today's show is all about SMARS paper, or Paper SMARS. How we can use Fusion 360 to do some really fancy things designed for sheet metal working, sheet metal working, but we can do that with paper instead. We can create nets. So let's get into this. Today's goal is all about how to make a Paper SMARS, how to use Fusion 360's sheet metal feature. We can create a SMARS chassis using paper. I have one right here that I made earlier. And we can then print it, we can cut it out, we can fold it, we can stick it together, we can build a SMARS on the cheap without a 3D printer. And then we can look at some next steps as well. So the first thing I need to say is hi to all the new subscribers. So on Friday, I got a bit of a surprise. I check in to see how many subscribers I have on YouTube. So I was bouncing around, was it about 650-ish on Thursday night, Friday morning. And then all of a sudden, I was getting a new subscriber a minute, sometimes even higher than that. And I was like, what is going on? Is this some kind of bot thing happening? Is my channel being flooded by bots, like artificial subscribers that then sort of get culled off by the YouTube algorithm? But no, these are all legit subscribers, it turns out, all of them. So I was currently at, when I looked at this, 974. Let's see if that changes throughout the show, but that's where we currently sat at. For a lot of beginning channels, hitting that 1,000 subscriber mark is one of the first milestones, so I'm very, very close to that. So what happened was, as you probably know if you're watching this and you're a new subscriber, is James Bruton, one of my heroes. He did a challenge for his patrons and paid membership people, and he said if you have a video or if you have a project that you want to showcase on his channel, just let him know, and he'll include that in a potential new video. He did it the previous year and the year before, so I thought this is ideal. I've got loads of projects to show him. I've got like the Pico crab. I just look behind me, I've got the whole load of them. There's these tiny little SMARS mini robots. We have Pico crab and all the other stuff I've worked on as well, the open cat and whatnot. So for me this was kind of an ideal scenario to share what I love doing with somebody I look up to. So yes, on Friday morning James released that video, and boy oh boy did I get a bit of a kick from that. So loads of people came in as new subscribers. I got loads of new comments, people saying, why have I not seen this content before, and so on. So if you're watching and you're a new subscriber, awesome, thank you for joining me. So Ethan says, who else is here from James Bruton? And James is a fellow Brit as well. So Tom says hi. Good to see you too. So yes, if you've not seen these before, unlike James's, which are pre-recorded, I do these live, and then they just get stored on YouTube for playback later on. So they're a little bit more interactive, and you can talk to me throughout the show, which is it's good for me. Makes my life more interesting because I've got more stuff to talk about on the show. But today it's all about how we use Fusion 360. So let's get on to that, shall we? So it's the sheet metal feature in Fusion 360. And as you can see there in the little line diagram, we've got a SMARS chassis. And SMARS, for people who are not familiar, are these little robots. I'll just grab one off my shelf here. These little robots, which are 3D printed, they use Arduinos and a motor shield, and 9-volt battery and two N20 motors, and they've got little tracks on there. You can develop them further. You can make them Bluetooth. You can make them controllable. They can have their own code in them, so they can detect distances with these little rangefinders, and they're very cute. And they're all modular, so you can sort of pull these pieces apart and interchange different pieces. So again, if I just go to this sort of wide shot here, you can see I've got a whole shelf load of these. Make sure I can speak into the microphone. I have a dumper truck one here, which has got, you can see there, a little dumper truck. We have a forklift truck variant. So there's a forklift version. And there is all other different variants as well. There is several walking ones on the back there, so quad robots. So I've done plenty of videos on them. You can look at them if you're interested too. So Fernando says, just subscribed. Fantastic, thank you. And your work on InMove is just amazing. I'm way behind where you're up to on there. And Sebastian says, I love robotics. Thank you for helping me a lot. Absolutely, that's what this channel is all about. It's about sort of sharing what we know. And I'm learning too, so you're learning with me. That's my premise. You're learning with me as we build robots together, we bring them to life with code and have a whole load of fun along the way. Cool, so let's get into this, shall we? Right, so Fusion 360 metal feature. So this allows you to create designs in Fusion 360 in the way that you normally would, and then you can unfold them into a flat piece. And the idea is that you would then send that off to a CAD/CAM machine, and it would cut out a piece of steel or aluminium, and then you would bend it on various different places. So yes, it's something that we can do, and we can use this to print out things such as the SMARS Paper SMARS. So this is just a regular sheet of paper. I've used quite heavy cardstock on this one. I think this is 120 gram. Just looking up, I've got all my paper up on my shelf there. The thicker the cardstock, the more robust the SMARS is going to be. It is paper, so bear that in mind. It's not quite 3D printed, the sort of solidness of that, but it's good enough. So this means we can develop a SMARS chassis and make it, unfold it like a net. If you ever did that in school, in maths, we did nets, and it was all about unfolding objects. I love that kind of stuff, as you can tell. So it's all about flanges. So a flange is a protuberance. It's a ridge, a lip or a rim on a piece of metal, and what we are going to do is extend that using the flange feature in Fusion 360, and that's how Fusion will know to unwrap at that point. It creates this sort of bend, this hinge, and that's what we'll basically be using throughout the entire build today. So if you like these kinds of videos, I always ask people to sort of hit the like button, subscribe to the channel, hit the little bell, doing that the wrong way around, hit the little bell, and then I'll get notified, or you'll get notified when I put a new video out, and I'll get notified that people like these things or they don't like them, or, this kind of stuff. So it's a bit of feedback, I get to see what's going on. So let me just go back to, oops, there we go. Okay, so material matters. So in Fusion, we have in the sheet metal section, so there's a sheet metal tab, and we'll look into this in a minute on the demo. So yes, there's a tab which is called sheet metal. In there is a sheet metal rules, and that's where we have to define our paper, because it's set up for, I think it's just metal sheet steel, and that comes with a standard kind of thickness, and we need to adjust all those different things. So the thickness of our card or paper stock, that's one of the first things we need to change. So there's a thickness set in there, so I've set that to 0.8 millimeters. That's probably thicker than card, but it works well for this particular modeling, so that's fine. There's a K factor. I've got a slide on that in a second to explain what that's to do with. We can pretty much set that to 0. That's fine. Hey Plasma, you caught me live this time, which is good. Last time he was complaining that he missed, so great to see you live. And then we have the miter, rip and seam gap. Again, I've got a slide on what exactly that means, but there's quite a few settings below that we'll get into as well, which is about bend and corner conditions. They're a bit more advanced feature, so we might cover it, we might not, depends on if we have time. The main one is the thickness, the K factor, and the miter, rip, seam. So let me just jump back to that there. So the K factor, this is a formula that Fusion uses to add material to the length of one of the dimensions. So if we think we have a piece of steel, for example, and this is what this is designed for, when we bend that up, it's going to compress the inside of the bend, and it's going to stretch the outside of the bend. And that bend itself is going to take away from the entire length of material that we have a tiny amount. So whatever the bend radius is there, that's going to kind of steal it. So if we had, so one of the key dimensions, for example, on SMARS is it's 70 millimeters long. So if we put on there 70 millimeters, and then we add to that a wall of 32, and then we bend that up, it's going to take off that entire dimension there, a tiny fraction. So what the K factor does is it just adds that to the length and takes it into account. So it's quite a clever little calculation. We don't need to worry about that too much because we're dealing with paper, and the folds in paper are pretty thin. It gets thicker with card, but it's not a problem for us. We don't need to be that accurate. It's 1/100th of a millimetre when it comes to paper, just because of the thickness. But yeah, K-factor accounts for that. In effect, it adds a bit of material to the dimension. Then the miter rip seam gap. So we're going to start out with a base, and then we're going to extrude up. We're going to use flange tool to extrude up 4 different pieces, and they're not going to be joined together like they are in a regular SMARS chassis. If I just grab this white chassis that I've got here, so that's got corners, and those corners, if I just zoom in there, are completely round because it's 3D printed and it's printed from the bottom up. Whereas this is going to be a sheet piece of metal which is flat, and we have to bend the corners up. So the corners are going to have a bit of a seam on them. And what Fusion has to do is rip the pieces apart. And the distance between those, which you can see in that sort of round circular area there, that is the gap between the edges. I mean, we can extend that and we can make that really narrow depending on how we want that to behave. So that's what this miter rip and seam gap piece is all about. Then we have the edge and bend relief types, and again, this is a bit more of an advanced thing, but I just thought I'd cover it on here because I came across this. So there's different types of relief shapes that we can have. So this is where, when we have those corners, and there's like 3 dimensions, you can see just on this little 3D view here, what do we want that corner piece to look like? Do we want it to be this sort of round shape, rectangular shape? Do we want it to be closed or just simple? And then there's different bend relief. So these look similar, the rectangle and the ob round, but it's just this tiny little sort of armpit area here. So on the rectangular one, it's very straight. On the ob round one, it's just rounded, and then on tear, it just tears next to it, but then stops. So these things, if you think about the rectangle and the ob round, where the bend actually is, which is defined by this line here, it's creating a bit of extra material next to that, and the rip goes further back, and that means it's got a bit more give. Whereas on the tear one, there's going to be a lot more stress on this corner here as the material meets the other piece. So it depends how we want that to be. Do we need to have a tiny bit more flex in the material, so we can use rectangle or ob round? And it depends on what we're building, depends on how we need to use these. And that ob round and that rectangle makes me think about, there was an aeroplane built by the British in the 50s or 60s, was it? Might even be earlier than that, that was called a Comet, and it had square windows. And where the square windows were, the pressure that was inside the aircraft and all the different stretching of the fuselage and everything as it went higher into altitude and faster, and all the friction, it created immense stress on those corner pieces. And this is why we don't have we don't have square windows in aircraft. We have round windows, because the stress on a round thing is spread more evenly, whereas on a corner, it's the actual corner pieces that creates the stress. So that's why we might want a rectangular or ob round. It just diffuses the stress more evenly depending on what we want. So that's what that's to do with. It can also be to do with if you're milling this piece with a CAD/CAM machine, and it's got a drill bit that's sort of moving around. The circumference of the drill bit might be what we use for the ob round. It just makes it easier to machine rather than trying to get a perfect corner. So that's what all that's to do with. We don't need too much to worry about that on our paper-based design. We're going to be using scissors to cut this out. So creating the design with flanges is a normal process of using Fusion 360, but there's just a few cases where we want to pull the material up using the flange to let Fusion know that that's where the bends happen. We'll do that in the demo in a second. Once we've created the design, we then want to unfold it, and this is where the Create Flat pattern button comes in. So you can see there just on the screen we have this little button. It looks like an unfolded net, and that's the Create Flat pattern button. So we'll press that, and then we will get a new view with just the single sheet of everything unfolded, which is quite satisfying to see. So what we need to do is just select the base from where that pattern is going to unfold from. So that's going to be kind of the centerpiece where all the other pieces unfold from. So if you think about, if I just pull up this sheet of paper here, that middle piece there is our base, and that just happens to be the bottom of our chassis. We're using a plastic one. It's just that piece in there. Okay, and then that's it. Once we've done that, we get that in a new view, which is the sheet metal unfolded view. And if we then want to take that and create something that we can print out from it, so a PDF that we can print out, then we need to bring that in as a drawing. So to create a drawing, we go to the design button drop down, which you can see just here. We click on that, we select drawing at the bottom, and then from design. And that will create, well, this is while we're in the flat view. We'll create the design from that. It will then go over to the drawing mode, and we need to make sure that we've selected A4 or letter, whichever is your standard paper size. In the UK, this A4. In the US, it's the letter size. So you want to make sure you've got it the same as you intend to print out on. And then next up is, in the actual drawing itself, we need to make sure the scale is set to 1:1. So you can just see there, 1:1 is the scale, and that makes sure the dimensions that we put into our package are the correct dimensions. So they need to be 1:1. If it's, I think it's 1.1 to 2 that it defaults to, so that would shrink everything down. We'd end up with something that doesn't fit our Arduino and our wheels and all the rest of it, and our motors. And then all we then do is just press the export as PDF button, and we end up with a PDF we can print ourselves. So that's what we're going to be doing today, and we'll get to it in a second. But I've made one for you. Here's one I prepared earlier. When I was growing up in the 80s, there was a kids' TV show called Blue Peter, which I think named after a ship for some random reason. Anyway, it was a kids program, and they always had a section where they made things. They always they had like a toilet roll tube inner. They had bits of paper. They had washing up liquid bottles, and they would sort of stick everything together and create something amazing. And they always had this phrase, like, they would, rather than doing the complicated thing on camera, they would just go, and here's one I prepared earlier, and it was like perfect. There was like no mistakes in it, no glue, no fingerprints, no bits where you've made a mistake and tried to stick it back together. It was perfect. So that's why I said this is one I made earlier. So if you haven't got Fusion 360, or you just want to get the thing, you can do. I've created 3 of these. If I just go to the overhead camera for a second. So we have a sort of a florally grass type pattern. I've got a camo version, and I've got a plain one where you can just put your own designs on, or you can use coloured cardstock, whatever you like. So that kind of thing. And this is just a printed out one, which is just on the plain one, as you can see. So let's go back to the main camera there. So there's £4 for each design. That can help support the channel. And I've just shown you how to do this, and I will be showing you on the demo. So you can always do it yourself if you have Fusion. If you just want the thing and you want to be able to do it and you want to help me out, then it's £4 per design. If you're a member of buymeacoffee.com/Kevin McAleer, then you can get it for £2 as well. I think I have a couple of members, so you can get that little discount there if you're already a member. So like I said, there's 3 designs. There's the white, this camo, and the grass. You can see them there sort of fanned out for you. If you wanted the links directly, you can see them there, but I've also put them in the YouTube description, so you can find them there too. I think they are probably not in the Facebook description, but they are on the YouTube one. So if you're watching this on replay, that's where you can find them. So after you've done this, after you've printed this out and you've cut it out and you've, stuck it together and everything, you might then want to think, well, how is this actually going to work? So I was thinking, like, what else could I do to make this a SMARS robot? Because obviously we're just working on the chassis there. So if I just take this thing apart that I've got in front of me here, and I just show you what I've done. You can add wheels, you can add motors, you can design your own rangefinder. They're the next steps, really. I've got one here I printed out with a camo design. I put a piece of card in the bottom. I've just used, just get this off here, some record cards. So these are sort of, they're not massively thick on their own, but I've just used about 2 or 3 of these together, cut to the right shape. And then what I've then done, and I'll show you a picture of this in a second, I put the motor inside a little sort of squarish box shape to hold the motor in place, because that motor is going to want to twist around, and the paper, if you just left it in there, it would just spin around when you apply power to it, and we want it to sort of turn the wheel instead. And I was thinking, if we haven't got a 3D printer, what could we use as wheels? So I've used corks, and corks pushed into the motor. So there's actually a motor in here. I'll show you that in a second. And I then use some cocktail sticks. This is very Blue Peter. For the other wheels, which I've just put into the side of this. I do need to think about how to make these a bit less wobbly, because at the moment there isn't much holding that together there. But then we can add our Arduino and motor shield. That can go in as usual. I just put that in place there. And then, in fact, if I spin that round to that side there, just show you this. And then we can add, I've got a 3D printed rangefinder here. That can actually just slot into place there. It is drooping down a little bit on this one because this was just regular paper, and I've actually not glued these in place. This is all just tabs holding this in place. So yeah, it is a bit Heath Robinson, but it does actually work. So I'm just going to put that down there. Okay, back to our Keynote. And you can add the 9-volt battery, you can add the motors as usual, just to a piece of card. Corks work. You might find a better thing for wheels. I don't know, bottle tops, whatever. There are different options there. You need to get creative with this if you haven't got a 3D printer. So here's the example of my cork build. So I got a piece of record card, like I said. You can see the motor is just stuck in there. That's the N20. You just need a little hole there for the wires to come through. There's a sort of top view of it. And then I just carefully push that into place, pop the motors through the holes. And what I did with the paper there, I got a file. So this is just a round file. If I just show you this on camera, sort of close up. So this is a round file. I think they're by Mac. And yeah, I just sort of poked that through just to make the hole there, just to make it a nice round shape. That was a bit fiddly to get at with the scissors. But the rest of it's fine. I then cut out these pieces here because they're going to fold over, so they end up being like a hole. If you look on our diagram there, that's these areas here. So when you fold them over, they're easy to cut. And then there's just the front and back, which the regular SMARS has, like so. It's got like these cut out pieces front and back. Okay. So we can see there with the motor shield in place. So the other thing I want to just remind people of is I do go live every single Sunday at 7 PM GMT. And I say GMT-ish because obviously when I put these slides together, I wasn't thinking about British summertime. So this is probably, is it spring forward? So that's probably 6 PM GMT, 7 PM British summertime. So ish. While we're here as well, if you've not visited the website, I run a website that's called smarsfan.com. On there is all kinds of tutorials, videos, code, lots of stuff. I did used to have a shop on there. I'll pause that for now. But if you want to get details of all the stuff on there, the links to all that parts, electronic parts and components, they're all still on there. So I will be doing a major release of smarsfan.com shortly. I'm still just ironing out some of the last pieces on there, which is to do with the learning platform. So there's going to be 4 new learning things on there. There's going to be a Python 101, a Robotics 101, how to build a SMARS, and how to build a SMARS quad robot. There are some tutorials on there already, but I've kind of gone the extra mile on these ones. So that's the website. We've talked about the video. This is the slide I normally say. We go live every Sunday, 7 PM GMT, and there's all the different time zones as well. And then finally, the last call to action I've got is if you wanted to support the show, you can go to buymeacoffee.com/Kevin McAleer, and that can help pay for all this equipment that I have, which is very expensive, ridiculously so. I'm not making a penny out of this show, I promise you. The royalty-free music I have in the countdown timer, which I then cut off, I have to pay for that. I have to pay for the graphics software, the streaming software, equipment, and so on. You get the picture. I'll not slog that one to death, but if you want to help out the show, that's how you can do it. Okay, so before we get into the demo, I just wanted to ask for some feedback of people. So when I do my shows, I think about it from these 3 different perspectives. So we've got designing the physical robot. So this show is very much around the design and engineering side using Fusion. We have the programming side where we look at code and Python and Arduino code. We focus in on that. And then we have the electronic side where we look at components and maybe new boards to plug into our robot, servos and stuff like that. And depending where those things overlap, you might be a tinkerer, a maker, an engineer, or in the middle, a roboteer. So what I want to know is, what do you want more of? Do you want to see more Fusion stuff? Do you want to see more 3D printing and that kind of thing? Do you want to see more programming? Do you want to see more electronic stuff? So if you comment below or leave a message in the chat, I'll pick that up and I'll get those messages and I'll look at that more because I want to create more of what you want ultimately. Okay, it is now demo time. Cool. Let me bring up Fusion and let me get to the right view. So I'm over here in this little bubble now. And So Andy's saying code and electronics, awesome. So this one's probably not for you then today. Right, what we're going to do, we're going to create a brand new sheet in Fusion, and when I need to, I'll sort of just move out of the way. I think I can do that, not that one, I can do that. That's a slightly zoomed in view, but we can address that. Okay, so I have kind of one, here's one I built earlier, and if I just put this back into the regular shaded mode, we can see this is a 3D model that we can move around. So this is kind of what we're shooting for. Okay, so let's go back to our main screen. I'm just going to switch on the layout grid so we can see what we're doing. So if you've not used Fusion before, I'll go at this at a reasonable pace so you can kind of keep up with this. The first thing we're going to do is we're going to click on this sheet metal tab here, and then we're going to go over to create sketch. I would normally say create a component, but for this one, we're just going to be working on one thing. It's fine just to create it without doing a component first. Component is if you've got extra things that you want to build into the design. So we're going to create a sketch, and then we need to select which of the faces do we want to work on. So there's all these different faces. We want to work on the top view, so I'm just going to click on top there, and then I'm just going to click there. So we're now in the sketch mode, so we now create a two-dimensional sketch of the base. So Andy's saying, what do I do as a day job? So I'm a project manager. I work as a freelance project manager for various different companies, and I've worked for many different companies. So I'm just going to hit R on the keyboard, and I'm just going to come over here and just press this center rectangle. I could actually go up to here and do a center rectangle just there as well. And what that means is it's just going to generate the rectangle from a center point. And this sort of weird looking cookie thing here looks like a BMW sign. That's the origin, and we want our design to be locked to that origin. And that means that our design is defined properly, and when Fusion is applying all of its things later on, everything will be locked into place. So let's just create that. I'm going to click, and I'm just going to drag out. And before I click anything else, I'm just going to type in some dimensions. So SMARS robots are 58 by 70. So I'm just going to do 58 by 70, hit return, and we've now got a fully defined rectangle, which is based around this origin point. And the reason we do it around the origin point is if we want to mirror things later on, it makes it really easy to do that because we've done it along this red X line. Okay, so we can finish that sketch now. So that doesn't actually have any dimension yet in space. It's just a two-dimensional drawing. So what we need to do is extrude it up. And normally we would just hit the extrude button. We would just come over here and we would hit this extrude. But this time we're going to do something different. We're going to hit the flange button. And the flange, when we click on this face here, is going to add automatically a thickness. I've not defined what that thickness is, and my little face is just covering up this flange box. I'm just going to move this over here for a second. And it says, what sheet metal rule do you want to apply? So I'm just going to select OK for now, and I'm going to do one operation, and I'm going to change the sheet rules to show you what this is all about. I'm also just going to change the visual style to shaded as well on there. Shaded with visible edges, and just give this nice little outline to it. Right. So normally we would extrude, we might design something on one side, or we might extrude the thing entirely up and then hollow it out with a shell command. This is different now. So we're going to use this weird sort of L-shaped thing that's called flange. So if I click on flange, and I'm going to click on this edge here. And then what I can do, I can pull this up, and can you see what's happened there? If I just zoom in on that, it's created a bend. And I can also do Option on the Mac, and I can select the other edges that I want to extrude up as well. And you can see there what's happening. So I'm going to type 32. That's the height of a SMARS. I don't think it applied that then, actually. Let me just go back to that. And just where it says height, I'm just going to change that to 32. There we go. So at the moment, this is sheet metal. This is really thick. This is steel. We don't want steel, we want paper. So you can see there what's happening. We've got a bend, we've got that seam between them, that gap. And that's not really going to work for paper. We need it to be a bit thinner than that. So this rule up here, it says switch rule, or we can go up here to the sheet metal rules. And again, I'm just going to move this out of the way so you can see me. And what I'm going to do is I'm going to edit this. I'm going to click that little pen button there. And where it says steel, I'm going to change that to card stock. And I'm going to change the thickness. Instead of it being 2.5 millimeters, I'm going to say it's 0.8 millimeters. I'm going to say the K factor is 0, and I've got my other dimensions just written down on here. Just a sheet next to me, just to make sure. And then the miter rip seam gap is going to be the same as our thickness. It's going to be, in fact, I could leave that as thickness. So thickness is a variable, like so. I think it's got a capital letter, that's why it's still red. There we go. And then I'm just going to open up these other two as well, because I think they have some extra things we need. So we don't want that bend radius to be the thickness, we want that to be 0.2. So I got these from another video online I think I found, which was just showing you how to do paper, how to apply these same rules to paper. So that's where I've got these figures from. I've not figured these out myself. So that's going to be 0.4, and this is going to be 1.6. And then I think there is one last one in the 3, just scroll on there, 3 bend intersection. So they're all the same. That last one there, instead of being, no, that is thickness, that's fine. Okay, so I'm going to save that. And now immediately, if I close this little window out here, we can see that the material is thinner, much thinner. If this was paper, it would be card stock. But we can see there, it's the gap is much thinner at the edges as well, this seam. Okay, so what I'm going to do next then, I am going to do another flange. So I want to create some little flaps that will come out and tuck in like that, and then there's going to be another piece that goes over the top, and that's going to lock these pieces into place, these tabs. So what I'm going to do, if I just press that little house button there, I can get it back to my default view. It's going to be this inside edge here. So I'm going to go and press flange again, and it's going to pull this out by about 20. That seems to be a good number, so I'm just going to type in 20 there. And then I'm going to move around the other side and just press Control, like so, on there. That's no good, that's the wrong side. Let me just do that again. So it should be that inside edge there, and that inside edge there. And we want to do the flange, and we want that to be 20. Perfect. And if I can do the same on the other side with the same operation, it just means we kind of save operations. Now it's complaining at the moment at the bottom, my face is kind of covering this error message up, but what it's saying here is that there's an error. It's clashing with the material. So if we look here, that thickness there is clashing with the thickness from there. So what I need to do is, where I've got this bend position, we do want it to be adjacent, but we want it to be on, is it the outer face? We just quickly find the right setting for that. So I thought it was inner faces, and there we go, inside, that's better. Right. So we're just going to make sure we have the correct option selected for that, because otherwise it'll clash with the material that already exists. So I'm just going to go back and double click onto to this one here. And I'm just going to hold down that option key, and I'm just going to select that edge there. Why is it doing the wrong one? I think it's selecting the outer edge. Yes, it is. I want it to be just the inner edge, which is that one there. Perfect. And then if I can just switch around to there, just carefully select the right edge. So it's that one there. Perfect. Okay, they're good. So there's 4 edges. If I just zoom out a bit. So can you see what's going on there? There's 2 lots of tabs on each side. And now what I want to do is I want to get this edge here and do another flange. And this is going to go over the top and then over the other side. So this is going to be, I'm guessing, about 2 millimeters. Now again, it's complaining about the flanges intersecting the body. You can see there it's actually intersecting. We look at this piece here. So what I need to do on here is just select the right thing. I think it's adjacent. There we go. So it's now popped up slightly above. They're slightly exaggerated, which is fine. And what we're going to do now, if I just get this view into place, is I'm going to select the very bottom edge of this line here, and I'm going to extend that down with another flange. So now we're going to go all the way down. If I just Press the home button so we can see what we're doing. Maybe that side's easier to view. And it should be the whole height, so about 32, I think it is. Let's see. If I type 32. Yep, it's not complaining about that. Good. Okay. And we can do the same on the other side. So can you see what we've done there? We've created two flaps and then we've created a piece that goes over it. And that's going to lock that into place. And we can make that lock even better by putting an extra little tab that goes through a hole so that it can't go past. I tried this and it works a charm. So what I'm going to do, I'm going to grab that edge there. Let me just zoom in so I can actually see I've got the right edge. So it's that inner edge there. And then we're going to create a flange. And that's going to be 2 millimeters. And then we're going to grab that bottom edge and we're going to extend that down with another flange by 32. Perfect. Okay, cooking with gas. So what I want to do now, I want to do two cutouts. So I'm going to click on this view here. I'm going to create a new sketch and I'm going to create two circles very quickly. So C for circle, I'm just going to drag out two circles. I don't care what size they are just yet. I'm going to do D for dimension and the circles are 4.5 millimeters. So now that I've created one, I can just click on this equals, select one and select the other. And the other one will get the same size, that'll be 4.5 as well. And if I also click this vertical horizontal button, I can make those both vertical and horizontal with each other, like so. And again, it's just one less dimension. So I'm going to do D for dimension, the center of it, and then the edge, and that's going to be 8. Oops, when it stops there, 8. And if I do the center and then the bottom, drag that out, that's also going to be 8. And then this one to this side is also going to be 8. Like so. Cool. So I'm going to finish that sketch and now we're going to extrude those two holes to cut out the material. So if I just press Q and then I select that hole and then I select that hole and then I just push them, push that arrow all the way through. Just messed up my selection there. All the way through like that. I can then select the distance as all and it'll just do it the distance it needs to. And now we've got 4 holes, and those 4 holes, if we have a look, go through all the different pieces of material there. So there's an outer piece and then there's an inner piece that it's going through, as well as the tab. So it's going to lock that tab into place as well. So they're the holes, and then there's another cutout. I'm just going to do that on this same side. I'm going to do it as a new sketch just to keep my sketches nice and clean. And this is a kind of trapezium shape. So I'm pressing L for line. I'm just going to do a nice trapezium type shape. It doesn't have to be perfect because we're going to do some constraints that are going to make it perfect. So press L. If I move along this line here, that X is going to change to a little triangle, which means it's the midpoint on that line. I'm going to click and then I'm going to drag it up until to this line here and then wait for that little triangle to appear. So that's a midpoint on that line. If I now press X on that line, it makes it a construction line, and then we can make that vertical like so. And then finally what I'm going to do is I'm going to do a line, so L for line, from that origin point to the very center of there, just to make sure that locks into place. I'm going to select that line and press X to make it a construction line, and then we then use the collinear to make that top line collinear with the top of our design. But it's still blue, which means we've got one last dimension to do, so D for dimension, and it's the height, so from the bottom to the top, and that's going to be 10.5. I remember all these things off by heart. We still need some more dimensions. We need to dimension this bottom one, so that's going to be 16, and the top one is going to be 28. This is how many times I've designed SMARS robots. Right, let's just have a look what's going on. So what's going on there is I've not made that line vertical. So if I click that, the design's now black, which means it's fully defined. And in fact, I want to show you, I'm going to undo that last step for a second, so that we've got the edges are blue, which means the sketch isn't fully defined. And can you see there's a little pencil on here? When I click on that line there and I press this button here, watch what happens to that little pencil. It changes to a padlock, and that padlock means it's fully defined, everything's locked into place, nothing's going to be moving anywhere. So I can finish that now, and I can grab that and the top piece next to it, and then I can do Q to push pull, and I'm just going to cut out that that piece all the way through like so. And we can see inside now, which is interesting. And the distance, I'm going to set that to all. I'm going to click OK. Hi Lee, how you doing? And you can see there's the actual cardstock. We can probably look and see the little tabs inside just peeping through there as well. So that's pretty much it. There is 2 more front and back cutouts. We can do them. Now you might consider, do you really need to have these front and back pieces? It does make the design a bit weaker, but it does mean you can attach things to the front. So I would say have a play with this to make up your own mind whether you think this is worth making it look just like a SMARS or whether you want a bit more rigidity to your design. So that's all I found on there. So what I'll do is create a sketch on there. And I think we have a couple of rectangles that we need to draw. So I'm going to hit R for rectangle. I'm just going to draw out 2 rectangles first. I know that the height of one of them is 7.5. And I know that the width of one of them, if I've got my little book full of measurements, one's 47. I think this one is the one that's 52. I'm going to say 52, and then the other one is, oops, this one here, I think this is one that's 47, and that has a height of 17.5. Okay, so now they're still blue because they're floating around. If I grab this, you can see it's not locked into place. So my little trick again is to do L, find the origin, click on the origin, draw a line up to that center point there. When it changes to a triangle, and then press it, and I'm going to make it X for a construction line, and I'm also going to press that vertical constraint. I'm going to hit on the collinear, I'm going to select that top line and then that line there. That's now turned black, which means it's fully defined. So L, and let's find the origin point. Let's select the top of the line there, which is the midpoint. We can see there we've got that nice midpoint floating around, so we can make sure that collinear, that line is collinear. Sometimes it doesn't quite work right and you have to just press escape and go back in. I don't know why that is. So collinear to there, and then finally we just click on that and make that vertical. Perfect. That should be the 2 things that we need to use to create the cutout. So I'm now going to do Q for push pull. I'm going to select the 2 pieces I want to push through. Just going to move this selection box just over there for a second, and I'm going to push this all the way through the design, and I'm going to do distance as all, like so. And then there's another piece which has disappeared because it's our sketch has disappeared, so I'm just going to turn that back on, and it's these 2 little pieces just here and here. So I'm just going to select them, do Q. Now they don't go all the way through. I'm just going to drag them like that, and then I'm going to turn the design round. And then instead of doing all as distance, I'm going to say to object, and I'm going to select that inner face there. And that will cut out just those 2 pieces. And then we can turn off that sketch. In fact, let's turn all them sketches off, like so. So that is our SMARS chassis. That looks pretty similar to what we had at the beginning. The only thing that was missing is that one was white in colour. So if I press A for appearance, it brings up this appearance dialog box, and I can search in there for paper. So if I do that, there's some white paper. If I just drag that onto the design, and then I just close out this this dialog box, which is now, I can't see the close button, there it is. We've now got our design. Okay, cooking with gas. So what we said we need to do now is we're going to click on this, where has it gone? Create flat pattern. So I'm going to click on that. It's going to ask me what is the stationary face, and it's the bottom there. So click on that, click OK. And now it's going to unfold everything, and look at that. That looks exactly like one of these, which is awesome. But that's still trapped inside Fusion. At this point, we can't print that out. So what we need to do, we need to bring that in as a design. So if I clicked Finish Flat Pattern there, it would disappear. And how do we get back to that? You can see there's a new little thing that's appeared, which is called Flat Pattern. If I click on that little I radio button there, we go back into the Flat Pattern view. And we can see there, these are the tabs, these are the bits that fold over, there's the holes, there's the motor spindle holes, And if I go to this design button here, click drawing, and then from design, I can then give it a name. So let's call this Paper SMARS Live. It's then going to say what kind of paper do you want to use. It always defaults to A3, so I'm going to select A4, and we want it to be the portrait mode, not landscape mode. If I select the wrong one, I can just change it in a second. So if I do that, click OK, wait for it to generate the page. So did I select the right one? No, I selected the wrong size. So let me just go back to I'm just going to plop that in the middle for a second. I'm just going to go over to these sheet settings, and where I've got the 297 by whatever, I just need to select the other one, which is the 210 by, there we go, 210 by 297. That's just the other orientation. Right, so now I click on my design. Now that design's too small. That isn't the correct orientation. So if I double click on it, there we go. You can see there the scale is 1 to 2. We need to change that to 1 to 1. And that means that our measurements, the 58 by 70, are all adhered to. And as long as the paper that we print on, and when we select the paper size, the page size, and the printer settings, everything should be exactly correct. So if I measure that with a ruler, or if I just get my original SMARS and put that into place, let me just show you on here. If I get the paper one, I get my SMARS thing there, and I put it on top of it. I don't know if you can see this, but that is exactly the right. I'm trying to show you there. That's exactly the right size. So that means all the other components will fit properly. Oops. So we need to go back to not Keynote, but Fusion, and then we can click Export as PDF, and that will save it as a PDF. So let's do that. Okay. Let's call this Paper SMARS Live. And then I should be able to open that up. So let me just open it up for a second. Just show you my face a second while I do that. So that was in the show called Paper SMARS, and it's the Paper SMARS Live. Right, this is just opening up now. So if I just go back over to that view there. So this is what you get. You get the view, which you can then print out. If I just hit the print button there, I've got a very cheap HP LaserJet printer just below me over here, and that should kick into life whenever it feels like it, because it does seem to have a mind of its own, this one. Okay, so you can use that if you want. What I've done on my designs, I've added an extra little tab. So if I just show you this here, this little tab at the top here has got a corresponding hole there, and when you fold it over, that tab goes into that hole and it locks it into place. And what I would say is, when you fold these out, should I cut one out here now just to show you how to do this? Let's do this on the overhead. Let's do it as quickly as we can. So we need to cut them tabs out like so, and so if you're not an adult, obviously you need to have parental supervision with scissors, because, you know, sharp things. My dad always says he's not allowed sharp things. Well, I've even put a little scissor icon on there for you as well. So let's do that. I'm just going to cut that bit out. So that also needs to cut out that tab just there. And let's just do that cut out there. So one of my friends on YouTube, Scissors Paper Paul, he has an entire channel about craft stuff. It's really worth checking out if you're into paper crafts. Scissors Paper Paul. He's an Australian, so he's on a completely different time zone to me. We always say he's on the bottom of the world. His point of view, I'm on the bottom of the world. Okay, so I've also labelled the tabs as well, so you can see. And these tabs, you can either glue them together with what do you call it, PVA glue, that sort of white glue. I've got some glue that I use for my 3D printer. I'll talk over here so you can hear me. I've got some 3D printer glue that I used before I understood any better about 3D printers, and I used to always put down this white glue on the print bed before I printed everything, and every single print I would print out would have this awful sticky mess on the bottom, and you could not get it off for love nor money. So I don't do that anymore. I just have a decent surface to print on. So I use the magnetic Ender 3 Pro print surface, I don't know what you call them, and that works fine. I did try printing on glass, but plastic doesn't stick very well to glass. Right, so I just need to cut out these last pieces, like so. I've not cut out that tab there. Okay, so that's everything cut out to begin with, and then what we then need to do is just fold pieces over like so. I've not cut out that piece there, but that's fine. We need to fold these tabs. Again, the thicker the card you've got, the more stable this is obviously going to be. Like so. And if you print out one of the designs that's got the pattern on it, or you colour in your own design before you print it, you can do some pretty interesting things on that. You could even just print one of these out and stick them to the outside. You could print stickers if you like. Okay. Like so. Now this is the fiddly bit, because there's two very close pieces that need to be need to have folds on them. They're about 2mm apart, so it's quite tricky to get them to work right. I'm trying to rush this just to show you, so that we don't take too long. Not doing too bad on time actually, so that's all good. Right, so now that we've got those like that, you can see these tabs need to go into this area here, but we haven't actually cut that out yet. So if I just get the scissor and just give that a bit of a poke, like so, and just do that on there, it means we can then get our scissors into that to cut that out. And you probably don't need as big scissors as this. I'm sure finer scissors would be much better. These are the ones that I had to hand though, so this is what we're using. Hopefully you can see that, yeah. I'll check back on the comments in a second, so if you've got any questions, just pop them in the chat, and I'll get to them momentarily. And the interesting thing with Facebook and YouTube Live, I'm using something called Restream, and Restream sends it up to all the different channels. So I'm currently on Twitch. I am on, I think I might still be on Periscope, but although I'm sure they shut that down, didn't they, this past week. I'm on YouTube, and I'm also on Facebook. I'm in the SMARS group. I've shared it to that. I'm on my personal channel, and I'm also in the Small Robots group. So if you're not a member of the Small Robots group, you might want to find that one out as well. So the other thing I want to do, these cross-hatched areas here, I want to cut them out too. So you might be saying you didn't see them when you go through Fusion 360 and you print the PDF. You don't get these cross-hatched areas, and that's because I've taken this, I've gone into Illustrator, and I've added some extra bits to it just to make it a bit more easy to work. So let's just do those last big pieces. So I am rushing this, I'm sure you can do a much better job. Okay, and okay, that's the last piece there. So now we will fold these pieces up. They're the tabs, like so, and then these bits fold over the top, and that tab should lock into that hole. Can you see how that works? Like so. Now it's best if you use some kind of tape, not just relying on the tabs, because you can see it sort of bends in a little bit there. But there we've got the SMARS chassis, and it is the right size. If we get our Arduino and motor shield, it does fit in there properly. So it does hold it. And with the motors, what I've done, as you can see on this one here, here's one I prepared earlier. If I just take this off, if I take these corks off the edge of the motors there, what I've done is I've created, I just pull this out, try not to rip it all apart. What I've created here is I've just got one of these record cards. I've cut it into a small strip, so I've got one. I've just checked the dimensions in there. If you remember, it's about 58 by 70 more or less, but we can probably eyeball it on there, to be honest. So let's just do that. And these cards are a tiny bit longer than we need, so let's just cut it off with that red mark actually. What I would do is I would just get a few of these. I've got 3 there. I would take them together. My printer's just literally kicked in now. There we go. And that will, if we glue that to the bottom, it gives it a bit more rigidity. You could use card or cardboard, and then you can create that kind of shape where you get one of these, you get your motor, which I haven't any to hand. Not going to hand. And basically you just wrap this round and fold it into like a square shape, like so. So you can create like a box kind of shape. And then I just used loads of tape, to secure that in place. I've even created some like little bridge pieces there. I don't know if you can see them on there, little bridge pieces, and that just stops the motor from sort of twisting round, because in a regular SMARS chassis, we've got these nice little walls, and the motor sits in there, and there's no way it can rotate. The wall there and the wall there are keeping that motor in place, and we have another piece of plastic, these pieces which go over the motor and lock it into place. So we haven't got that on this one, so we have to make do. And then what we do, we get our trusty little stabbing file thing, and we just go through that hole there. So I'm just going to work that until I feel it through the other side. Doesn't take very long for it to do that. There we go. Okay, and then we'd work that hole a bit better, to be honest, but you can see where I'm getting at there, and that's where the motor would poke out of. So it would poke through there, but sat on the inside like so. And that's how we make our SMARS chassis. So obviously we need to work on creating a rangefinder holder. So that's probably the next thing to design. And these ones are made up of 3 pieces. So you've got your actual HC-SR04 rangefinder. Oops, push that through the wrong side there. So we have these pieces. So there's like a bracket. I'll just do that. There's a bracket there which holds the rangefinder in place. That rangefinder just pushes through there. You can see what happens. We get it roughly center. And then this 3D printed piece, it's got a little standoff there to stop the thing pushing all the way through. So it just gets to the right place and then stops. And it just fits in perfectly like so. So that's the 3D printed version. We need to come up with something similar, but using the techniques that we've just looked at today. So that's one of the challenges I've set you guys if you want to take that on, and just get in touch with me on the Facebook group, either in the SMARS community or in the Small Robots community, and send me a link to your design or just show me what you've done. So I'm hoping you found that really interesting and useful, and if you're new to the channel, you found that as you expected, and please let me know what you want to be working on further. I'm just going to pick up that piece just printed out just down here. So that's what we get from Fusion. So it's pretty plain, and that's why I thought I'll take that and I'll make it a bit more interesting. So if you want a nicer printout and you want to help the channel, you can purchase them through the Buy Me a Coffee link as well. I did used to have a button for that, but that seems to have disappeared now. I don't know why that's gone on. Let's see if I can find that. I did have there it is, the widget. Just a little on-screen widget for Buy Me a Coffee. Should appear there. There it is. So yes, let me know what you think there. I'm going to look through the comments now and see what people have been talking about. So all the people are saying hello. We had that beginning. So Sebastian was saying this is his very first live chat, so he's excited about this. So it's good fun, isn't it? Yeah, you can talk to me. There's probably about a 20 to 30 second delay between me saying something and then me seeing your response to that. And that's just because of all the different latency that the different channels put in place. And all places like YouTube and Facebook, they will do voice recognition in reasonable real time, and it just needs to add a delay to do that so that you can see what I'm saying as a transcript underneath. And what else have we got? So Andy was saying that he wants more code and electronic stuff, and he was asking me what my day job was. So I'm a project manager during the day. And somebody says, Maestro, I unfortunately don't speak. I'm guessing that's Spanish. I could put that into a translation engine, but I'm not great at that. So Tom says, regarding your question, what are you looking for? I'm looking for the next step, implementing AI neural networks for SMARS. Awesome. So I did do a video on some of this a while back. I did a video on speech recognition and speech synthesis, and that was using the ReSpeaker, which I think I've got in my drawer here. Where's that gone? I've got a whole bag of them. There it is. So I had a Raspberry Pi Zero, and then there's a little hat on the top there. I don't know if you can see that. And that's called a ReSpeaker. So if you Google ReSpeaker, you'll find the provider of that. And they've got an audio in and an audio out. So this has actually got on board 2 tiny little microphones. I don't know if you can see one where it says left and right. Those are the... my fingernails look terrible on that, but they're actually... I think there's a bit of a cast of light. I've not got bad fingernails, honestly. That one looks really yellow. Don't know why. Anyway, so there's a microphone left and right, and then there is the audio out as well there, and then there's a whole array of like speaker outputs as well. So that has that presents to the Raspberry Pi Zero the 2 microphones, and it does the sort of spatial stuff for you as well. But then you can put that into Python. You can use the text-to-speech, Pi text-to-speech X3, I think it's called, Pi TST X3. And that'll do the text-to-speech thing, so you can just give it a string of characters and it will say them. And it's pretty good, sounds pretty awesome. And then the one that converts the speech recognition one, I think it's literally called speech recognition. And that can use the Google speech API, so you just send text and you get back a audio that you can play back. No, sorry, you send audio to it just by plugging the microphone using Python. You plug the microphone in, it sends off whatever data to Google, and then you get back a string of text that's recognised. And you can just have a loop going over and over and over that. And you can basically just look for a watchword. So you can say, when that phrase equals, "Hey robot," you can then say, go down to the next level and then look for certain keywords, and then, you know, make the robot go forward, make the robot go backwards, whatever you want to do. So I did do a video on that one. You might want to check that one out. And I also did one on object detection. So I had, again, using a Raspberry Pi Zero, a Raspberry Pi camera. I gave the quad robot, so I think it's the one at the very back here, this one that's got the camera on it on the front there. Grab him. So that one has got a camera, it's got a Raspberry Pi Zero in it there. And this is the SMARS quad. So if you've not seen these before, it can walk on its own. And that camera can do object detection, so it can see faces, it can detect smiles, it can detect frowns, it can detect different expressions like that. It could also detect other objects that you choose, so you can do classification. So that's a pretty interesting one. There is a video I watched recently about Arduinos and training them, so we could do something on that, but Arduinos are not really great at doing classification. It takes a while to do. Essentially, you've got to go through as many nodes there are in the neural network. Each one of them has a connection to every other node in that layer, inputs and outputs, and each one of them has a weight, and it's those weights that the training adjusts, so it can take quite a while to do that. Whereas on the Raspberry Pi Zero, it's got a bit more grunt, so you might want to look at that. So yes, I did a video on speech recognition, speech synthesis, and then another one on object detection using the Raspberry Pi Zero and a camera. So you might want to look at that. That's all good. What else has we got on here then? So Lee says hi. Hi Lee. So John B says you could stiffen the thin card or paper with shellac-based knotting compound or superglue. That's very true. Yeah, so you could like varnish it in effect afterwards. Shellac varnish. That will certainly stiffen it up. So Christopher says, can you use the drawing and share outside measurements for original SMARS? Sure. So if you go to smarsfan.com, you'll find all the measurements. So I've done several videos. If I just pull this up and then just share my screen, I can show you what I'm talking about. So if I go to smarsfan.com, and if I go to the Learn, is it? And then Design Studio. On here, I've got this is the very first video I ever did actually, so you'd have to forgive me being a bit nervous and a bit quiet. But on there, I will talk through exactly how to do the chassis. But also, if you click on the chassis page, look what I've got. I've got all the dimensions for you, such as that 58 by 70. It talks you through step by step, and it uses Fusion 360. You can see all the different screen grabs, all the different dimensions, all the different cutouts, and everything you need to do, all the different operations to create your own SMARS chassis. The interesting one on that is using the revolve feature to create the, where has it gone? The wheels have little wheel stubs, and it's a nice feature of Fusion that you can do a revolve. Just trying to find it on here. There are all the different bits. Must be, there we go, wheel stub. So you define the profile, you sort of push that in, and then you define the profile, and then you revolve it round. That's my favourite feature, that. And then you do a little cutout so that you've got a bit of give when you push the thing on. It can sort of squeeze in and then pop back out. So you get that wheel shape. So that's how to create the what I call the community edition of SMARS. So I didn't create the original SMARS, I've got to put it out there. That was the genius that is Kevin Thomas, and that's why I call it SMARS Fan, not smars.com. SMARS Fan is the fan site that I run with all the information about SMARS robots. So if I just scroll back up to the top there. So that's how you build the chassis. We've got the wheels, how to design them and all variants of them, the tracks themselves. They were an interesting little project. The motor holders, we've got the range finder on there as well. And that's just the SMARS. There is, did I do one on SMARS Quad? I can't remember now. But yes, that's, and we've got like the build instructions there if you want to, how to build each of them. And there's this sort of step-by-step instructions. This is a piece I'm currently redoing as the new learning platform for SMARS. All the electronic components, if you want to know about like the line follow module, you can read about that, what they're called. Now, I did used to have a link you could buy them, but I've had to close that shop. It wasn't profitable at all. I made a massive loss on that. So here's me trying to be the big entrepreneur and just losing loads of money. And there's the modules. So we've got like the forklift, which I've shown you, the Caterpillar tracks. We've got 3 battery mods. The ultrasound, which we use regularly. We've got the line follow module. There's a Lego mod. Now I was thinking about doing a Lego mod. On that one, they're the little pin pieces of Lego that push in. I was thinking about doing the more traditional blocks that poke out. I don't know what you call them, but they're like the regular kind of Lego. I'm sure I've got a piece of Lego in here somewhere. So if I get a piece of Lego like this, those 8 blocks there, I was thinking about doing a SMARS mod using Fusion 360 because you can get the dimensions for these very easily online, and I have actually designed one already. So that'd be a nice easy show for me to do. So that's one of the mods there. What else we got? There's one for doing soil moisture. I do actually have that. I've not built one of those yet. There's the shovel mod. There's a colour sensor. It's quite an unusual and rare component. I couldn't get hold of that in the country. And then there's this SMARS Zero, which uses a Raspberry Pi Zero and camera. And then the quad. So the quad's a nice builder on its own. So you can see there I've got all the different information for all the different parts, all the different build instructions, electronics, the works. And then if you want code, I've got different code libraries for different uses. So yeah, if you go over to the play section, then there's lots of code. If you go to the lessons page, if you want to know how to move a SMARS around, then you can go to the SMARS and there's a video on that. And again, there's like a write-up with line by line explanation of what each line of code does, all the different variables, all the different functions to make your robot go forward to control the motors. So that's lesson 1. There is several lessons like turning the robot left and right, how to interface with the sensors. That's got a nice animation on range finding. Then we've got positioning sensors. So how can you detect using accelerometers, digital compasses, Bluetooth. That's a good video, often looked at. How to control servos, and then the line follow module as well. So, Christoph, if you want to know what the dimensions are, just head over to the Learn section and go to the Design Studio, and you're probably after the chassis, which is that one there. Cool. So that's that question. Next up, we have Lego Blockchain says hi. So yes, you might want to look at that Lego mod for SMARS as well. I'm sure there's some pretty cool things we could do with Lego and SMARS. I do actually have the full. Is it called Lego Mindstorms Inventor Kit or something? I've got one of those, and I've often thought about SMARSifying that, making a SMARS robot out of Lego. I've got enough Lego to do that. I'm sure that's something we could do too. So Christoph says, thanks for that. Awesome. So yes, that's the video for today. I hope you enjoyed the content. I love doing these videos. I do them every Sunday, and I try and squeeze in a midweek one if I can as well. And the SMARS paper one is something I've been waiting to do for quite some time. I've had that as an idea, and I just didn't know how practical it was. And it turns out it works fine. I'm not quite satisfied with the wheels yet. I think this is a bit of a bodge, but I'm sure there's something we can do better than that using some of the components. So I'm open to ideas on that. Remember, it's learn with me. This isn't me just teach you everything perfectly. This is me throwing some ideas out there, you know, giving you an idea of what we can do. One of the videos I've not done, and I thought with all the new people joining, that I might do a video, just sort of a tour of the studio, really, just show you all the different bits and pieces. You know, I've got all the movie posters at the back there. I've got some bits and bobs up in these top sections here. I've got these funny looking things at the top here, which is, let's grab one of those. All the different pinouts for the Raspberry Pi Pico. So this is if I'm working on something and I just want to grab what are the measurements, I can just very easily do that. And I've got an in-move just behind me there. You can't see, but there's also, if I sort of move out the way, there's his arm just there. There's another arm there which I've not put on. I've not built his shoulders yet, and his head. Where's his head gone? He's just there on a little turntable. Also got a Mac Classic there. It does actually work. And then behind there you can see an original BBC computer, which does work. If I plug that in, you'll hear the dirt sound. It works fine. Let's try that. Just for a bit of nostalgia. I just need a monitor to plug it into. So that works fine. And then on here you can see all the different robots I have as well. So we could do a bit more of an in-depth video on them. You can see I've got the Open Cat there, I've got the Pico Crab, I've got an Auto DIY, and I've got a whole range of SMARS quads as well, 3 of them, and loads of SMARS just off camera here. I've got all these SMARS robots as well. So there's about 7 of them. So if you're interested in any of that, just let me know. I could do a midweek video on that too. I've got some other ideas as well. I've got a whole load of ideas on my wall here of other stuff to do, but that's why I was asking for some viewer feedback. You want more code and electronics, less fusion stuff? Happy to do that too. Great. Okay, thanks everybody. I'll continue to look at the comments because sometimes there's a bit of a delay, but I'll answer that on the replay as well. So see you next time. Thanks for joining. Thanks everyone.